Hi, everyone. Welcome to CE 321. We are today talking about highway design for performance. So we're talking about how do we measure performance of freeway operations, traffic operations in general. And there are two concepts we are going to talk about here. One is the Freeway LOS, which is the level of service. And we are going to specifically focus on the freeways. Freeways are sort of divided highways that have at least 2 lanes in each direction. And then access to the freeways is always grade separated. It's never, it's never accessible directly via a stop sign or a yield sign with an at-grade intersection. It's always grade separated access. This is a quick example of sometimes you will see the sign of begin freeway or end freeway as you're driving down, for example, on US 101 highway here in California. You'll see these signs, and what they mean is that in the segments that you're going to encounter from that point forward, where you see the sign begin freeway, that means there would be no at-grade intersections with US 101. And then when you see the signs end freeway, that means for the next few miles, you can expect to encounter some at-grade segments. So we are talking about level of service on freeway segments where you are not expecting to encounter any at-grade intersections. And because that's not happening, we treat that flow as an uninterrupted flow facility, and the level of service estimation is what we are going to learn here first. And then we'll also talk about a little bit about queuing theory. And queuing theory is interesting because it can be helpful in, when there is a queue that builds up in traffic anytime, and that could happen in uninterrupted flow facilities, but also on interrupted flow facility. For example, on a traffic signal, a queue could form, and you can analyze that using the same theories that we're going to learn here. And then you could also analyze queues that happen on freeway, for example, because of a collision or a crash that closes the freeway lane and interrupts the traffic that way, sort of a sudden interruption. You could analyze those queues using queuing theory. So in both scenarios, queues could develop, and you could analyze them using the concepts that we're going to learn through queuing theory. And again, queuing theory is important, obviously, from being able to estimate the delays that traffic might encounter, but then also at signalized intersections, for example, delays are also sort of primary ways of estimating what we call the level of service. Okay, so I'm going to go ahead and start sharing my screen. And this is chapter 3 of your textbook. And what we are dealing with here is the concept of measuring the performance of a roadway or a highway. And we're going to start with more uninterrupted flow facilities, and that is the freeway. So now when we talk about uninterrupted flow facility, I want you to recall the discussion between speed and flow rate. Okay, speed and flow rate, and we did in chapter 2 when we looked at the Green-Shields model, where we assumed a linear relationship between speed and density. Remember, we recall a linear relationship between speed and density that looks something like this. If you had density d on the x-axis, okay, so if you had density d on the x-axis and speed on the y-axis, this is what the relationship looked like. And then if you did have some relationship like this, your flow speed relationship that you're able to derive then looked something like this. It's a parabolic relationship. And as the flow increases first, the speed comes down. And then at some point it reaches capacity. And then obviously you could have more demand at that point, but flow rate cannot be exceeding than this because the traffic will sort of jam up and not as many vehicles would be able to pass the highway points. And then flow will drop overall, and then the speed will drop as well. Now, when we sort of look at this phenomenon of what happens to speed as you increase the demand flow rate, the real world picture looks a little bit different than what a theoretical Green-Shields model between speed and density that represents a linear relationship between speed and density would indicate. So instead of this parabolic type relationship, what happens in real world is that you can actually add some traffic. And this is something that we talked about a little bit when we're talking about traffic assignment, is that this is more of an exponential relationship between speed and flow rate. I think we were looking at travel time there, and travel time and speed are obviously related with each other. As speed goes up, travel time would go down. But the idea here is that you can actually maintain the speed at a pretty high level. FFS, remember, that stands for free flow speed, which is the speed at zero density, and in this case, zero flow rate. So basically, if you're the only driver on the road, you'll be able to drive at the free flow speed of your choosing. And then as you add traffic, those added cars or added vehicles on the road would also be able to drive at the same speed. But at some point, a break point is reached. And then when we're doing the level of service calculations, this is the break point we want to identify. And there are formulas that are provided by the highway capacity manual that we use. And then at some point, the flow sort of drops. So the speed drops as you increase the flow. And then it drops in a certain way. And that curve might be a little bit more parabolic in nature. And then it reaches capacity C of the segment. And if you want to sort of look at this point here, that point corresponds to this same point here on capacity side. And beyond this, the relationship between speed and flow is somewhat unstable. And you could, if you go and check out the real world reading and you start observing the flow rate and the space mean speed of a segment and flow rate on any point on that segment, you start to see that the points will be sort of all over the place in the vicinity of this point, in the vicinity of capacity point. I think the highway capacity manual does show that somewhere if you look through it, and you could do that. So now what happens is that you can derive density, the density variable, the third variable. Remember, we have three variables that sort of define the fundamental relationship in uninterrupted flow, that there are speed and flow rate, and the third one is density. So density is actually just prevailing speed. So if you want to define density, D is equal to, remember, Q is equal to S times D. That was our fundamental relationship. So anytime you want to define the D value, it's Q divided by the speed, where S is the prevailing space mean speed. So if you're given this speed flow rate curve, you can derive the density at any given point. So for example, you could see the density sort of going up at this level. So you could define your density based on, so let's say if I want to find the density, so I'm going to just kind of put some points down. So I'm going to draw some points here. Just drawing some points on the curve. And at all of these points, if I want to find density is basically flow rate divided by the speed, okay? So you could see, so if you want to find the density, it's the slope of joining that line from the origin, because remember, it's flow divided by density. So the way I'm going to define the density at any of these points is that slope of that line, of that point, slope of the line that joins that point on the curve with my origin point on the curve. So I can derive density at all of these points by looking at the slopes of these lines that I'm drawing here. And obviously the line joining to the capacity is already drawn with a dashed line. But if I estimate the slope of these lines, I can get my capacity. And how do I get the slope of these lines? It's just rise over run, as you know from Professor Bertini's videos that I've posted before. The slope is just rise over run. So I could get these slopes by doing the flow rate divided by the density. Now, the other thing that you might notice between these two curves is that I'm defining my flow rate as passenger cars per hour per lane. And I'm sort of trying to standardize the flow rate by accounting for that I might have different types of vehicles in the mix. For example, I might have a lot of heavy vehicles in the mix. And if I do have heavy vehicles in the mix, I want to be able to sort of account them and convert them into passenger car units. So each car will take, I mean, each truck will take up more space than a car. And then I try to convert each of those cars into each of these trucks into passenger car units. And then I just define those units as passenger cars per hour per lane. And so instead of, and then I do it per lane as well, so that I can compare a 2-lane freeway with a 4-lane freeway or a 6-lane freeway or whatever, right? So that's why my units are a little bit different. So this is the curve that you find in our manual, which is called the highway capacity manual. And it is published by Transportation Research Board every few years. And we are right now, we are on HCM 7, version 7, and that just came out late 2022 and early 2023. But the good news for us is that because we are only dealing with freeway level of service for this class, for the CE 321 class, because we are only dealing with the freeway level of service, we can pretty much work with the HCM version 6, okay? Now, this is something that you have to keep in mind, that the example problems that are in your textbook, you know, they may not be the most appropriate example, or at least they may not be the solution to those example problems in your textbook, may not be readily applicable. So that's why what I've done is that I have provided you in your Canvas page. If you go to your Canvas page, I'm going to go ahead and clear the annotations here. On your Canvas page, I've provided you the actual chapters from the HCM version 6. So if you look at this, you're going to be looking at HCM v6, and chapter 12 is what defines the basic freeway and multi-lane highway segments. Now, in this class, again, we are only dealing with the freeways, so we're not going to worry about multi-lane highway. We're just dealing with freeways here. So basic freeway segments are what we are going to deal with. We're not actually having to deal with multi-lane highway segments. But remember, chapter 12 does deal with both. But we are only going to focus on the basic freeway segments. And then, so this is your chapter. And then here you can find the basic methodology. So you can find, if you go scroll down, you can keep going down the list. And it talks a little bit about conceptually what an urban 8 freeway looks like, what a 6-lane rural freeway segment might look like. And then you have sort of, you know, this is the real data point. And I was saying, like, you know, as you reach the capacity points, as you reach sort of your capacity points, your flow and density relationship becomes pretty unstable. So that's why you see these points all over the place. And this is sort of the step by step. This is a chart that I showed you earlier on my slides. And there is this managed lane concepts. Again, we're not going to deal with that. So this is managed lanes are your high occupancy vehicle lanes and HOT lanes. And again, because we're just starting out scratching the surface of this freeway capacity in this CE 321 class. So again, we are not going to worry about this stuff for this class. Okay, so we're not going to worry about this managed lane concepts. So don't worry about this at all. And then what you're going to start dealing with here is this methodology that talks about how level of service is basically a letter grade, A through F, and the grade depends on the density. Now, why does level of service depends on density? Now, think about it this way. Level of service is a way of sort of grading the operation on a freeway how user perceive it. Now, if you're driving down on a freeway, you are most comfortable when the freeway is sort of empty and you can drive at whatever speed you want to drive at. And if you can do that, then you have the best experience driving on the freeway. And that's why we use density as our sort of how we grade the freeway performance, because that's how driver perceive the performance. If the density is low, drivers feel good driving on the freeway. But if the density is pretty high, so for example, if the density is like more than 35 passenger cars per mile per lane, then drivers don't feel good about that. And that's why when we are grading the freeway, we use this density as our sort of performance measure to define, to grade the level of operation. So level of service is nothing but a level grade. And this is sort of the LOS criteria, the level of service criteria on basic freeway segments. And again, we use the same criteria for multi-lane highway segments as well. But again, we in this class, we're just dealing with the freeway segments. You can demonstrate that graphically as well. Okay, so you could see that if you draw these lines on this chart, different areas represents different level of services. And then these charts are a different level of free flow speed. Free flow speed is what the freeway looks like when it's empty. And you could sort of place this chart. And again, there is a corresponding chart for multi-lane highway as well. So again, we're going to deal with freeway level of service chart. We're going to deal with this chart. But again, for this class, we're not going to deal with this chart, which is for multi-lane freeway segments. So we can deal with this chart, but we're not going to deal with this particular one that deals with the multi-lane freeway segments, or multi-lane highway segments, sorry. Now, a step-by-step of methodology is provided in this PDF. And again, you don't have to look at the whole thing, but what I do want you to do is just kind of look at this overview of the methodology that provides the step-by-step. And again, this methodology is for both multi-lane highway segments as well. So this methodology is very similar, but focus on equations that are provided to you just for the basic freeway segments, okay? And then the computational steps you will see in another video that is recorded by Dr. Kimberly Mastico that I've also provided on your Canvas page, and I'll link that to this video as well. So that's the video from Dr. Kimberly Mastico that goes over those step-by-step that I just showed you, okay? So please go through that video as well. And then in addition to chapter 12 from HCM6, I've already also provided chapter 26. By the way, this chapter 26 is sort of a supplemental that is provided by Highway Capacity Manual, folks. And Highway Capacity Manual itself, the volume 1, 2, 3 are not available for free. You have to purchase those PDF, although because for classroom purposes, I have provided you with the snippets of chapter 12 already. But for chapters 26, if you want to look at those, and those are provided to you because they have these great examples problems. And those things you need to be able to work on using this. And again, I want to sort of tell you, these are provided to you because I want you to look at these example problems. So definitely look at example number 1, example number 2, example number 3. So look at these 3 problems. Don't look at, and then look at this example 6. That's it. So I want you to just look at 1, 2, 3, and 6 example problem and make sure that you understand all the steps involved there. And again, you don't have to worry about problem 4. You don't have to worry about problem 5, and you don't have to worry about problem 7, because problem 7 deals with basic managed lane segment. Problem 5 deals with mixed flow freeway operations, and that basically gets into, when you have different types of trucks in the mix. So we won't worry about that right now. And then example problem 4 is about 5-lane freeway. So in this chapter 26, this is for example problem. So look at example problem on the freeway and multi-lanes facility in segment 6. Just look at example problem 1, 2, 3, and 6. And those would be sufficient for your purposes. And then go back here and then watch this example problem for Freeway LOS as well. And that's also provided. And that's a YouTube video by Dr. Mastico, where she goes over those step-by-step of the problems for you. Right? So again, this is what I mentioned, that again, you will notice that these chapters, one thing I want to quickly note is that these chapters are actually from HCM6 that came out in 2016. So if you look at the bottom version, it says version 6. But if you look at you can go to, you can actually go on Google search on the 7th chapter. You can find the National 7th, and that part is not free. But again, 6th and 7th edition are no different when you're talking about freeway level of service that we are dealing with. They're exactly the same. And then the other thing that I want to talk a little bit about is that in case you can actually go and figure out, so I'm going to pause the recording for just a second. So as I was saying, that HCM version 7 is the latest version, but again, because 6 and 7 are identical, I've only provided you the HCM 6th edition for our purposes. And obviously, there are some key critical differences that you can look up online. But for the freeway level of service, there is no difference between version 6 and version 7. And the other thing I want to talk to you about is that what is not available for free are the volume 1, 2, and 3 of the highway capacity manual. But the highway capacity manual volume 4 is freely available. And what's there is the supplemental chapters starting from chapter 25. These are all freely available. And you could actually download the chapter 26 for version 7 from July 2022, which is pretty new. And you could download the latest version of that for free if you go to this link right here. If you go to this link right here, hcmvolume4.org, hcmvolume4.org, if you go here at this link, you can actually download this, the newest version. But what you'll notice is that if you go to chapter 26 and you look up the freeway example problems in this, chapter problem 1, 2, 3, and 6, if you look at the problems that I want you to look at, 1, 2, 3, and 6. So these problems are exactly identical. They're on different page numbers, but they're exactly identical between the volume 6 version and the version 7.0. So again, you don't have to look it up, but I just wanted to make sure that you're aware of that the HCM volume 4 is freely available resource. But again, you don't have to go and look that up at all, because all of what you need, even though I provided it from version 6, these problems 1, 2, 3, and 6 are exactly identical, and you could look those up, those problems. And then you could follow along with Dr. Mastico's video to learn about how to apply the methodology in chapter 12 to solve some of the problems that are discussed in example problems that are provided in chapter 26. Okay. So that is that for highway capacity. And here are some things that I want to talk a little bit about that. That, when you're in this scenario, as a driver, you will feel that, you're very congested. You have to be stop and go. You have to be very alert in your driving. So that's your level of service F. Now, again, the density is a very good measure for cars' level of service on a freeway. But again, the same performance measure may not work when you're talking about bicycle, when you're talking about transit buses, when you're talking about pedestrians' level of service on a city street. So then, or an intersection, the intersection density won't be a good measure. So sometimes we look at vehicular delay as our level of service measure on intersections. So we have to select appropriate, level of service measures. For freeway level of service, it's the density on the road. But if you take CE 421 traffic engineering class, for example, or if you take sustainable mobility CE 527 class, for example, from our curriculum, you are going to learn that we use different performance measures that are related with user comfort and user comfort, that are related to user comfort. And so basically what best describes the user's level of comfort. So we try to use those measures to define level of service for those facilities. For freeway level of service, the density is what defines it. And that's why I use density as the criteria. Okay. So this is sort of is the measure, when we talk about, once we figure out the capacity of a freeway facility is the maximum hourly rate. And again, we try to define it normalized for type of vehicle and normalize it for number of lanes. And that's why our rate is, the units on this are usually passenger cars. So the units on this would be passenger cars per hour per lane. So remember that, folks, is that our capacity units that we use in highway capacity manual are passenger cars per hour per lane. And then once we have the capacity, we can go ahead and determine the level of service. And to do that, the 3 steps are: you figure out the flow rate, you figure out the free flow speed, which is the field measurement in miles per hour, and then level of service is the letter grade based on density. Now, how to do these steps? You'll have to check out Dr. Mastico's video that I'm going to link to this video, comments and description, and then you could watch that video, and it's also available on Canvas if you're enrolled in this class simultaneously. Okay, so I'm going to stop here, and I'm going to post this video, and then in the next video, I'm going to pick up the discussion of traffic queues. Thank you so much.